This is a Getty podcast.
Hi, I'm Lilit Sadoyan, the host of OM, our museum mindfulness meditation podcast, Getty's first video podcast. Welcome to this deeper dive, where we explore the themes of our weekly episodes with experts in everything from paintings conservation to the history of sleep.
Clouds are ubiquitous across planetary atmospheres, whether it's Earth, Mars's thin atmosphere, Venus's thick atmosphere, or the giant planets like Jupiter and Saturn. You see clouds everywhere.
This week, we did a thought clouds meditation inspired by Simone Denis' study of clouds with a sunset near Rome. To learn more about clouds and the way they capture our imaginations, I spoke with Marek Slipski, a scientist at the Jet Propulsion Laboratories in Pasadena, who researches clouds and climate on Mars. Now let's dive in. Hi, Marek. Thank you so much for joining us today.
Yeah, thanks for having me. Really excited to be here.
Thank you. So this week we focused on a thought clouds meditation inspired by a cloud painting by Simone Denis. And we are talking today about the significance of clouds, both physically and emotionally. Personally, I have been looking up at the clouds for a very long time, since childhood. We are all just so enamored by clouds. And I'm curious to hear from you why you think clouds are so appealing.
Yeah, it's a great question. I don't have the one answer to that, but there's something we see every day, right? And I think we've all had this experiences as kids and spending time outside watching the clouds overhead. But they're not static there, right? They move across the sky. What's there one day isn't there the next, but there might be something different. So they move in real time. But they're also ephemeral. They come and go. And there's something that's easy to connect with there, and kind of is a constant, but is also highly variable that makes them really interesting.
Mm-hmm. And like you said, they're ephemeral. They're constantly changing. They also can affect our mood, right? So what do you think about the emotional significance of clouds?
Yeah, I think you can imagine a storm cloud and the kind of cartoon image of a rain cloud following somebody. So there's obviously that like stereotypical kind of connection, rainy day type sadness association, but also the being outside on a sunny day with smaller clouds of different shapes passing overhead, and that being like a very relaxing Zen type moment. But I think there's also maybe a subconscious connection with what we all read about with respect to climate change. And even if we're all not intimately familiar with the kind of the physical connections of clouds with climate change, we see the weather changing every day, and we notice things like that over time. And so for some, maybe that's something that is not easy to express, but it's clearly there.
So what is the connection between clouds and climate change, or what can clouds tell us about climate change?
Clouds play a really important role in the climate. They can have two sort of competing effects. They both reflect incoming solar radiation, so they reflect sunlight, which acts to cool the atmosphere below, but they also absorb and emit in the infrared. They can have that sort of greenhouse effect and warm the atmosphere. And so the net effect is dependent on sort of the details, the very small details of the properties of the cloud, how big or small the droplets are, the size and shape of the clouds, right? We know that things can take up large areas and also be very vertically extended. And that might have quite a different impact than sort of thin cirrus type clouds. And a lot of scientists are really focused on this. When we run global climate models to understand how the climate is changing, clouds can be a big source of uncertainty, not just because they have this competing effect, but they show up in different places at different times. If you look at images of Earth from space, you'll see that day-to-day variability. And over time, that leads to uncertainty in the state of the atmosphere.
And as an atmospheric scientist, I know you care a lot about clouds in your role. How did you come to study clouds? Is this something that you were interested in from childhood, or do you have any early memories of clouds?
I do have those canonical memories of watching the clouds pass overhead, but I actually never really intended to study clouds. I've always been interested in planets, and I am particularly focused on Mars. I've always been interested in the question of, is there life out there? And Mars is one of these places that we can kind of scratch the surface of and try to test whether or not there is life elsewhere. And I've come at this from the sort of habitability side of things. So Mars today, the atmosphere is very cold and thin, and you can't have liquid water on the surface. But we know from the surface that there used to be liquid water. So that atmosphere 4 billion years ago was warmer, thicker, and something happened to change that. And so I've spent a lot of time focused on the upper atmosphere of Mars, above where you see any clouds, but where you can see the sun interact with particles in the upper atmosphere and drive them away into space. And over time, over billions of years, that atmosphere has been stripped away. But as I learned about the upper atmosphere of Mars, and I've sort of come down to lower levels, and not too far below that, there are high altitude clouds on Mars. We have high altitude clouds on Earth, noctilucent clouds, they're called, polar mesospheric clouds, where at nighttime you can see these because of the angle of the sun, and they actually, noctilucent means night shining clouds. You may have seen these outside. But we see similar things on Mars, and I've been studying those a lot recently.
Sounds so beautiful. So you're studying clouds on Mars. How are these clouds different from the clouds on Earth?
Yes, on Earth, all the clouds are water droplets, right? Water vapor in the atmosphere condenses usually onto a seed particle, a condensation nuclei, and you get liquid water in the atmosphere. And that's obviously what rain is. There are some clouds that have ice mixed in them as well on Earth. But on Mars, the atmosphere is very cold and it's very thin. And so just like on the surface of Mars, you can't have liquid water. You don't get liquid water in the atmosphere. That water vapor in the atmosphere freezes directly into ice. So you have a lot of water ice clouds on Mars, especially over topographical features like the volcanoes. But interestingly, you also find CO2, carbon dioxide ice clouds, dry ice clouds. And carbon dioxide is the main constituent of Mars's atmosphere. It's about 95% CO2. So the main constituent is actually freezing out because in certain places and at certain times, it gets really cold.
So can what we're learning about clouds on Mars reflect what we know about Earth and vice versa?
Absolutely. I think at a high level, there are only a few atmospheres that we can really study and learn about clouds. Which isn't to say that clouds don't form on other planets. Clouds are ubiquitous across planetary atmospheres, whether it's Earth, Mars's thin atmosphere, Venus's thick atmosphere, or the giant planets like Jupiter and Saturn. You see clouds everywhere. But these questions of the small scale of how different molecules condense or freeze and sort of the environments they need for that to happen are fundamental physical questions. So on Mars in particular, we're trying to learn a lot more about how these ices form, how you go from water vapor directly into ice, and how the seed particles that they form on matter and shape that process. For instance, these high altitude clouds, we're not sure whether the particles they're forming on are dust from the surface. Mars has these incredible dust storms, sometimes completely enveloping the planet. But we're not sure if those dust particles make it up to high altitudes where water vapor can freeze, or if it's meteor, basically particles from meteors that burn up in the atmosphere, where you get individual small particles, and maybe those are what these clouds are forming on. It's still an open question.
Well, we've talked about cloud watching here on Earth and looking at clouds from images in space. Do you have any suggestions for our listeners who would love to enter this meditative state with clouds?
I sure do. So I help lead a project called Cloud Spotting on Mars. This is a citizen science project where we use real NASA data that's come from the Mars Reconnaissance Orbiter, which has been at Mars for 20 years now. I work with an instrument called the Mars Climate Sounder, and we can identify clouds in our data. We're an infrared instrument, so the data we show volunteers aren't images of clouds, but the clouds have a particular shape to them, where you can find them and mark them, and we use that data to kind of look at the distribution of clouds and try to figure out what they're made of. But it's really been a lot of fun to do a citizen science project. This is my first foray into this. And we've had a lot of great conversations with participants in our project. And a lot have commented that they use it to enter a sort of meditative state, something that's very different from their normal day-to-day, where they could log in, start to find these clouds and enter a kind of flow state and engage with science. This is data that we use in research.
What a wonderful way to contribute to science and relax. Well, thank you so much, Marek, for joining us on the OM podcast this week.
Thank you.
To find the related meditation and see images, transcripts, and additional resources, visit our website at getty.edu/om. That's OMMM.